Hey y'all, how's it going? Miss G here, and we are going to be talking about 1.6 rewriting equations and formulas. Please make sure that you've got your blanks note page as you're going through this video. Fill it out as we have this as our last section of our chapter 1 notes. Make sure your name's on it as we are approaching that chapter 1 final test where you are going to have a notebook check, and I'm going to be looking to make sure that we have all your notes filled out for you. Okay, so let's dive right in. An equation that has two or more variables is called a literal equation. All right, so far, guys, we have been working with equations and we've been solving equations where this is an example of an equation from 1.5 where we had variables on both sides of the equation, right? But these variables were the same, meaning both of these were an x, and we were able to solve for that one variable. So a literal equation means that there are two or more variables. Some of the most popular variables that we are going to see would be x and y, meaning that both x and y are going to be in the equation, and then that means that we're going to solve for one or the other. So here in this last little blurb here on your notes, you can rewrite one by solving for one variable term in terms of the other variable. So if you were to have, let's see, you were to have 3y minus 5 equals 2x plus 10, it means that we could solve this and rearrange and use all of our solving steps that we have so far for solving equations, and instead of getting that x equals a number or y equals a number, we want it to look like y equals, and then we'll have all the other terms on the other side. Okay, so let's work through a few examples to make sense of this, all right? So the practice questions. It says to rewrite the equation to solve for a specific variable. So here on our first one, we have solve 2y plus 5x equals 6 for y. So when we look at the instructions, when it tells us what we want it to solve for, that's telling us we want it to say y equals and then everything else. So we're trying to get y all by itself. That's the variable that we are trying to isolate. So when we think about using all of our solving steps for equations, we're trying to make it look like y equals, okay? So here is our equation that we're working from, okay? And we're going to start with all the same steps that we've done before, all right? So first question is, are there any parentheses? No, there are no parentheses. Second question, bubble and box, right? Because we want to combine things together if we can. So I'm going to go ahead and use a heart because this has a y term. I like to use our bubbles for our x term. And then we're going to box in this 6 since it's just a number. So all of this is still the same as before that we've been doing since the beginning of chapter 1. All right? So now we have to go back to our instructions. It wants us to say y equals, which means we need to start getting this heart all by itself. Okay? So in order to get this heart all by itself on this side of the equation, we need to get rid of this bubble, which is a positive 5x. In order to get rid of this, we're going to subtract 5x. And when we subtract 5x from one side, what must we do? We must do it to the other. So since this is a constant term and it's in a box and not a bubble, I'm going to write it over to the side so I don't get confused and try to put these two things together. So when I minus 5x, I get rid of it on this side, and now I'm just left with 2y equals 6 minus 5x. So again, I have my equation, I made a change, and then I rewrite my equation. All right? So if I need to, I can still bubble and box again to make sure that I've got everything where I need it to be. And I say, okay, great. I have this y variable term all by itself now. Now it's time for me to actually solve for y, meaning make it look like y equals. So who is hanging out with y right now? 2 is hanging out with y, and it's being multiplied by y. So how do I undo multiplication? I'm going to use division. So I'm going to divide that by 2, and I'm going to divide everybody else by 2, which these 2's cancel out to 1. So I'm going to get y equals 6 minus 5x everybody gets divided by 2. All right? So the last step here is to simplify so that we don't have this big, long divisor bar all along this side of the equation, all right? So we're actually going to divide every term by 2. So do you see how the 6 was a term and the negative 5x was a term? I'm going to actually divide each of those by 2 so I can get rid of this divisor bar. It's just like multiplying something by 1/2. This is the exact same thing as 1/2 times 6 minus 5x, right? And we would distribute this multiplication. So here we're just going to distribute the division. So that's going to turn into y equals 6 divided by 2 is 3. Negative 5x divided by 2 is just negative 5 over 2x. And I am done. Because now I have y equals, and everything else is on the other side. All right? If it doesn't quite make sense, don't worry. We're going to practice in our practice problems, okay? We're going to talk about it in class, but just keep trying to follow along here in the notes, all right? So here I have on this second one, it says, the formula for the surface area S of a cone is this, okay? So this is the formula that they've given me. It says the surface area equals pi times r squared plus pi RH, or pi times r times h, okay? So in this formula, it gave us surface area, but we also don't know, they didn't tell us, but r is for radius, okay? Actually, let's just back it on up. Let's not get too much into the details of things. Let's stay focused on rearranging the equation, okay? So it says solve the formula for the slant height h, okay? So it means I want to make it, this variable look like h equals. So I have to rearrange this formula from what it currently is to say h equals instead of s equals. And we're going to use all of our solving steps to be able to do that, okay? So it does not matter that we have pi's and r's and all the things, okay? We're still going to treat it just like terms. So if we were to bubble and box everything, okay, I'm going to go ahead and just say that this guy can be a heart, okay, because he's just an S. This pi, this variable r squared, I'm going to go ahead and just put inside a box. And then this one is different because it has an r times an h. This r is not squared, right? So this one has to be a different shape. So I'm just going to circle this one, all right? So now I have to start figuring out, I want it to say h equals. So this is the term that I want to get all by itself, which means I have to get rid of this pi r squared. In order to get rid of it, I have to subtract it from this side of the equation. And that would mean I would need to subtract it from the other side of the equation. Do you see how I wrote it not underneath the s, because these two don't go together, all right? So then I would have, I'm going to say s minus pi r squared equals pi r h. All right, so again, we're getting closer. We want this to say h equals, but right now we've got this stuff being multiplied by h. So how do I get rid of multiplication? To get rid of multiplication, I'm simply going to divide by both pi and r. So those are going to cancel out, and I have to divide everybody by pi and r. All right, so when these cancel out, I have h equals, so I'm just going to flip this around. I'm going to say h equals, because there's my h, right? H equals, and then this is the other side of my equation. The surface area of the cone minus pi r squared over pi r. Now, when we do formulas, okay, formulas are something that are given, right? This is the formula for the surface area of a cone. You can't like change it and make it something different. Like that is the formula. We rearrange them like this so that if they were to give us the value for S or R, we could easily just plug them in. We could just plug in the values and then we could solve for H very quickly, okay? So that's the reason why we would rearrange a formula, okay? All right, let's dive into our last two examples. So even though this surface area one that we just did might have seemed a little bit confusing, I really want us to lock in on this temperature because we are going to see this temperature more, and as an 8th grade expectation of standard for equations, the expectation is that you should be able to convert temperatures and use this formula, okay? So let's kind of readjust and lock back in. We're going to start talking about temperature now, okay? So the instructions say solve the temperature formula, meaning this is what it is, right? This is the formula for it, something we can memorize or would be on an equation formula sheet for F. So when we're talking temperature, what do you think F stands for? I agree. F is for Fahrenheit. Ooh, I hope I spelled that right. And then C is for what? Celsius, okay? Hope I spelled that right too. If I spelled it wrong, I apologize. So when we talk about temperatures, it kind of depends where you live in the world, right? We tend to here in Oklahoma talk about temperature. It's 78 degrees outside. We don't say 78 Fahrenheit, right? But we are talking in Fahrenheit, whereas other places in the world talk in Celsius, okay? And this is the conversion formula so that if someone were to be able to give us the temperature in Fahrenheit, we could plug it in and we could solve for what is the temperature in Celsius, okay? So right now, when it says solve the temperature for the variable F, that means it wants it to say F equals. And right now it says C equals. So all it wants us to do is rearrange this so that F is on this side of the equal sign and everything else is talking about C, okay? So in order to do this, we're going to use our steps for solving, okay? So let's see, what would be the very first step? We would unlock parentheses, right? Okay, so one of the other ways that we unlock parentheses, as we've talked about, is when we have these fractional coefficients. Do we see this right here? So remember, when we want to get rid of a fractional coefficient, because eventually we're trying to get this guy all by himself, right? I have to get rid of this 5/9. One way would be to multiply it by everybody inside the parentheses, okay? An easier way to do it would be to first multiply by the reciprocal, which would be to multiply by 9/5. If I multiply by 9/5 on one side, I must multiply by 9/5 on the other. So when I talk about this all being locked in by parentheses, this 9 is going to cancel that 9. This 5 is going to cancel this 5. So now do you see how I've pretty much unlocked those parentheses? So my updated equation is 9/5 C equals F minus 32. All right? All right, so if I were to be looking here and I'm looking at my solving, I've now unlocked parentheses by multiplying by the reciprocal of this fractional coefficient. Now it's time for me to bubble and box, right? Okay, so I could say this has a C term, this has an F, and this is what I want to get all by itself, and this is just a number. There's nothing else for me to be simplifying. All I want to do is get this F all by itself. So I need to get rid of this minus 32 by adding 32. When I do it to the other side, I'm going to make sure I write it off to the side so that I don't try to combine these things together. And that's going to give me 32 plus 9/5 C equals F. And now I have solved the temperature formula for F. All right? And of course, you could write it on the other side. It doesn't matter which side of the equal sign you have the variables, as long as the signs in front of the terms are the same, right? Then it's okay. All right? Okay, so let's use this formula now to be able to answer the question of which has the greater temperature, the sun's surface at 11,000 degrees Fahrenheit or lightning at 30,000 degrees Celsius. So again, these units right here mean we can't compare these numbers yet, because we can't just say lightning is has a greater temperature because the units are not the same. It's like comparing inches and feet, right? You have to put them into the same unit before you make a comparison. So if we were to try to figure out, we have to figure out which one do we want to convert? Do you want to convert this one into Celsius, or do you want to convert this one into Fahrenheit? So I'm going to start with our original equation they gave us, where they told us that C equals 5/9 F minus 32. All right, that was what was originally given to us as a formula, correct? So what I'm going to do is I'm going to take this Fahrenheit right here, and I'm going to plug that in for F to be able to convert it into what is that temperature in Celsius. So I'm going to rewrite it as C equals 5/9 times 11,000 minus 32. And now on this side of the equation, I'm just going to evaluate now that I've plugged a number in. Okay, so I'm going to say the degrees in Celsius is 5/9 times 10,900 and what would that be? 68? Make sure that I'm doing my math right here, guys, okay? 11,000 minus 32. Yep, 10,968. Now I'm going to multiply that times 5/9, all right? And when I do that, the Celsius degrees for this first one is 6,093 degrees, okay, Celsius, all right? So that means that this sun's surface is actually 6,093 degrees C. So at this point, can we now figure out which one is a greater temperature? Yes, lightning is definitely a greater temperature at 30,000 degrees C. Okay, so this is where solving formulas helps, because then we can just plug numbers in very easily to be able to do so. In terms of your practice problems, we are going to be seeing a lot more of this number 1, okay, this example right here, and this is what we're going to focus on in class to make sure that we really know how to rearrange an equation and solve for a variable, okay? Bring your questions to class, and I'll see you there.